This lesson is about perfect square trinomials. Let's review some definitions. A perfect square trinomial is a trinomial that can be written as the square of a binomial, such as x plus 5 squared equals x squared plus 10x plus 25. Stop the video right now and verify that x plus 5 times x plus 5 really does FOIL to equal x squared plus 10x plus 25. You'll do FOIL first. X times x is x squared. Outer, x times 5 is 5x. Inner, 5 times x is 5x. That's 5x plus 5x equals 10x. And last, 5 times 5 is 25. So it really does work. The general form of a perfect square trinomial is as follows. X plus a squared is really x plus a times x plus a, which FOILs out to be x squared plus ax plus ax plus a squared, and you combine the middle two terms to equal 2ax. Also, you can have x minus a squared, which x minus a times x minus a FOILs out to be x squared minus ax, and again you combine like terms to be the minus 2ax in the middle. Notice that the numerical term in the binomial a is represented in the trinomial in two different places. The coefficient on the middle term is double a, 2a, whereas the value of the third term is a squared. This pattern will help us factor quadratic expressions. Seen another way, we can say x plus a squared is x squared plus double a plus a squared, and that's what we'll call it. X squared plus double a x plus a squared. Use the patterns to square the following binomials. For instance, x plus 3 squared. I can use the pattern to say it's x squared plus double a, or double 3, plus a squared, which is 3 squared. So it's really x squared plus double 3x plus 3 squared, which is x squared plus 6x plus 9. Let's try x plus 8 squared. It will be x squared plus double 8x plus 8 squared, which is x squared plus 16x plus 64. Here's another one. X minus 12 squared is x squared plus double negative 12x plus negative 12 squared, which simplifies to x squared minus 24x plus 144. Here's more examples. Use the patterns to rewrite a trinomial as a square binomial. For instance, notice in 20 and 100, 20 is double 10 and 100 is 10 squared. Therefore, you can rewrite it as 2 times 10 and 10 squared, which tells you that x squared plus 20x plus 100 can be rewritten as x plus 10 squared. You can always check your work by FOILing x plus 10 squared. Likewise, when you see x squared plus 14x plus 49, well, 14 is double 7, and 49 is 7 squared, which fits the pattern, so you can rewrite it as x plus 7 squared. Finally, x squared minus 12x plus 1, ooh, that should be a 36. Then negative 12 is double negative 6, and 36 is negative 6 squared, and so you can rewrite x squared minus 12x plus 36 as x minus 6 squared. Here's one more definition. If you are given the first two terms in a perfect square trinomial, you can identify the third term by squaring half of the middle term. For example, given the perfect square trinomial, x squared plus 20x plus something, identify the missing term. Well, remember the relationship. X squared plus double a x plus a squared is equal to x plus a squared. We can look at the given trinomial in the following way. Think of 20 as actually double 10, and therefore the term at the end must be 10 squared, which means our third term would have been 100, and inside our binomial it's actually x plus 10 squared. We know that 20 is double the value of a in the binomial, so a is 10. We can fill in the missing values, just like I just did. This shortcut for this method is the missing third term here is equal to the square of half of the middle term. In this example, the missing third term was half of 20 squared. And half of 20 is 10. When we square 10, it equals 100. So we'll want to remember the phrase, you can identify the third term by squaring half of the middle term. The following examples, I'd like you to identify the missing term of the following perfect square trinomials. For instance, 10. The middle term is 10. So cut it in half, that's 5, and then square it, that's 25. And I've written out the full chain of reasoning here, that 10 is really 2 times 5, and so the last term is 5 squared, and the binomial being squared is x plus 5 squared, and you get x squared plus 10x plus 25. Again, using the shortcut, the missing third term was half of the middle term squared. And half of 10 is 5, and 5 squared is 25. I'll do one more with you. Do these on your own, and let's try one with a negative. So, negative 30. Half of negative 30 is negative 15. And so the middle term is double negative 15. The last term is square negative 15. And so the term inside the binomial is negative 15. And our full trinomial, therefore, is x squared minus 30x plus 225. So the missing term was 225. Using the shortcut, the missing term is half of the middle term. Oops, that should be a negative 30. Which is negative 15, and negative 15 squared is 225. My, that was quite the typo. Go ahead and try out the remaining examples, and then go to the next screen. Here are some practice problems for you to do on your own. Identify the missing term of the following perfect square trinomials. Again, you take half of the middle term, which is 3, and then square it. 3 squared is 9. And half of the middle term is the term that goes inside the binomial. So this is actually x plus 3 squared. Try them out, and then check out the answer screen on the next page. Here they are.